Alright, so XAS sample making. Let's start with the most simple one, the one which is generally used on ligand K-edge measurements at beam lines 4-3, 6-2. Likely it's going to be the same setup at on 4-1. The idea is that the sample cell is a thin aluminum spacer, is going to be mounted on a paddle, and the paddle is 45 degrees angle relative to the incident beam, and the other side is the detector. So to make this sample, what we need is practically any kind of tape which is free of contaminants. Contaminants meaning here the chlorine, if you look at chlorine edge, or molybdenum edge, sulfur. If the sample is not air sensitive, that's the easiest. The sample cell prep involves practically just mounting the cell on this tape and checking, making sure that the tape is nice and smooth, even on the back. I generally avoid touching this window. And then the sample prep itself, what it takes is just a mortar pestle, and I'm going to use just an iron oxide, and generally I use a little boron nitride to try to dilute the sample as much as possible, minimizing self-absorption. So add a little bit, generally just enough. So for example, this is about the right amount, 3-4 milligram, and add a little bit more boron nitride. So just add enough so you can grind it and paste it to the sample. Grinding is, you can see it's lightly colors. Grinding is, there's no general rule of thumb. There's a nice paper by Ingrid Pickering and Graham George showing that you cannot grind it small enough, just simple mechanical grinding to avoid self-absorption. So there's no fixed way to do it. What I generally do is grind it and then collect in the middle, go the other direction, collect in the middle again, collect in the middle again, do it 5 times, again as much time I have. Obviously air sensitive samples, everything needs to be done in the glove box. And when it's done, if the sample is sticky enough so it sticks to the mortar and pestle, or if you have very little amount, you can use the pestle and then just dab it onto the surface. So practically about this much is enough, and then use the spatula and just smear it out. Again, goal is to have some sample on it so you can visually see it, but as little as possible, and practically the sample is ready to go. So the difference between the small and the large sample size is simple, just spatial difference. This can fit in a larger paddle, then fluorescence detection is used in front of a lidl window. This can fit on a smaller paddle, much more narrow, shorter paddle, and for example using electron yield.